Good morning, everyone. I am Caleb Emmanuel O. Frias from STEM12A, and today we're going to solve some physics problems from Chapter 22, Gauss Law, problems number 22.13, 22.15, and 22.31. First problem. Two very long uniform lines of charge are parallel and are separated by 0.22 meters. Each line of charge has a charge per unit length 5 times 10 raised to negative 6 coulombs per meter. What magnitude of force does one line of charge exert on a 4.9 times 10 raised to negative 2 meters section of the other line of charge? First of all, we're going to find the magnitude of force exerted on a 4.9 times 10 raised to negative 2 meter section of the other line of charge. So we're going to use the force equation, which is equal to the electric field times the charge. So in order to get the charge, we're going to derive from the charge density formula, which is lambda equals to charge over the length. So it will be equal to the Q equals to length lambda. So after that, we're going to substitute it in the first formula, which will become to F equals to 1 over 2 pi epsilon times lambda squared L over R. So after that, we're going to substitute the given values to the formula. And then after that, we're going to get 0.1 newtons. Next problem. How many excess electrons must be added to an isolated spherical conductor 40 centimeters in diameter to produce an electric field of magnitude 1170 newtons per coulomb just outside the sphere? So first of all, we're tasked to find the number of excess electrons. And in order to do that, we're gonna use the electric field formula, which is E equals to K times Q over R squared. And then we're gonna just use algebra to focus on finding the charge, which is Q, which will become Q equals to E times R squared over K. So we're just gonna substitute that the given values in the formula, which will become to 1170 times 0.2 squared over 9 times 10 raised to 9, which will become 5.2 times 10 raised to negative 9. So after you get the charge, you just divide it by the charge of uh, one electron, which is 1.6 times 10 raised to negative 19. And after you do that, you're gonna get 3.25 times 10 raised to 10 electrons. So the last problem, at time t equals 0, a proton is a distance of 0.36 meters from a very large insulating sheet of charge and is moving parallel to the sheet with the speed of 9.7 times 10 meters per second. The sheet has a uniform surface charge density 2.34 times 10 centimeters squared. So what is the speed of the proton at t equals to 5 times 10 raised to negative 8 seconds? So we were tasked to find the speed of the proton at t equals to 5 times 10 raised to negative 8 seconds. So we're going to use the Pythagorean theorem in order to get the magnitude of the speed. And then we're going to use the first formula, which is F is equals to ma, where m is the mass of the proton, which is equal to 1.67 times 10 raised to negative 27 kilograms. And then we will get the force, which we will get from the electric field times the charge, and the E is equal to sigma over 2 epsilon dot. We will just substitute the given to the formula for E, which is equal to 1.6 times 10 raised to negative 19 over 2 multiplied by 8.85 times 10 raised to negative 12. And then it will therefore be then equal to 132 newtons per coulomb. And then after you just multiply it by Q, which is the charge, which will then be equal to 2.11 times 10 raised to negative 17 newtons. And for A, In order to get the acceleration, we just divide the force by the mass of the proton, and you just substitute the what you got from the earlier steps, which will then be equal to 1.26 times 10 raised to 10 meters per second squared. So in order to get the final velocity for the y component, we will just use the kinematics. Vy is equals to initial v plus acceleration times time. So you just substitute the values from the given to the formula, which will then be 1.26 times 10 raised to 10 times 5 times 10 raised to negative 8, which will equal to 632 meters per second. And then you just substitute it to the Pythagorean theorem in order to get the final, or the magnitude of the magnitude of the speed, which will then equal to the square root of 970 squared plus 632 squared, and it will equal to 1.16 times 10 raised to 3 meters per second. Thank you for watching, and God bless you.